So welcome to this latest video on 162 Maths, and in this video we're going over 3D shape vocabulary, properties and nets. A big shout out to the 2025 7M1, 7N1 and 7P1 classes for recommending me making this video. So a three-dimensional shape is a solid shape that can be measured by its three dimensions, and these are commonly the height, the length and the width or the depth. Now common 3D shapes do have their own unique names. Now the most common shapes that you'll deal with in maths, and as there are loads of different kinds of 3D shapes you can have in the world, but the more common shapes that you'll have to deal with in maths is going to be either a cube or a cuboid, a cylinder, a cone, a square base pyramid, a triangular prism, a tetrahedron, cylinder and a sphere. Now a common type of 3D shape is what we class as being a prism. Now a prism is a polyhedron, which is a 3D shape whose faces are all polygons, and again, definition of a polygon is a shape with straight sides only. Now a prism consists of two opposite identical faces with their vertices joined by parallel lines, meaning that their sides are all rectangles. In some cases they can be a square, but that again is quite a rare case for a prism. And a prism has the same cross-sectional area all across its length. So what do we mean by cross-sectional area or the cross-section? Well, that's basically the shape that's repeated. So on a cube, that would be one of the squares. So this would be the cross-section. On a cuboid, which is represented by a cube, but it's been stretched, so you could say that this here, which is going to be a bit difficult to see on purple, so let's do that there. So this would be the cross section, and in fact when it comes to a cube or cuboid, any of the sides could be the cross section, so it's usually the one that you can see at the front. With a triangle prism, or triangular prism I should say, it's going to be the triangle, so that there is the cross section. And with a hexagonal prism, that's going to be the hexagon, and that there is the cross section. And so one way of defining a prism is basically like a pile of a polygon. Now another type of 3D shape is what we class as a pyramid. Now a pyramid is a 3D shape with a polygon base along with a triangular faces that meet at an apex or vertex above the base. Now the name of a pyramid is often described by the shape of its base. However, a triangular base pyramid is also known as a tetrahedron, and the reason why it's got a unique name is because unlike all the other pyramids, all the faces are the same on a tetrahedron. Now one of the most common errors is believing that a cylinder is a prism. Now a cylinder behaves like a prism because it has the same cross section all along its length. However, a cylinder is not a polyhedron as it doesn't have only flat faces, so therefore it's not classed as a prism. So if you're ever asked to describe the shape that you see, please don't write a circular prism, because obviously a cylinder is not a circular prism. Now often you may get asked to describe the properties of a 3D shape. Now the properties of a 3D shape includes the faces or the surfaces, the vertices and the edges. Now a face is a flat surface of a 3D shape, and it's really important to note that a curved surface is not a face. So on a cylinder that will only have two faces, that being the two circles, whereas the length is a curved surface, so it's not classed as a face. Now an edge is the intersection of two faces, or a straight line where two flat faces of the polyhedron meet. So in other words, if you imagine a transparent 3D shape, it's the number of lines that you draw to make that 3D shape. Now a vertex, or the corner of a 3D shape, is a point where three or more edges meet. So now let's have a look at some examples of what we mean. So here we've got a cube on the screen, and you can see here that it's going to have 6 faces. So let me just highlight where those 6 faces are. So we've got 1, 2, 3, 4, 5 and 6. And number of edges, so it's how many lines that we can see. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12, and the vertices are the corners. So we've got one corner here, one corner there, one there, one there, one there, one there, one there and one there, giving us a total of 8. Now it's really important that if you get a question where a cube is drawn like this, that it's not a case of how many you can see, it's a case of how many there would be if it was drawn accurately. I know that looks like a cuboid, so let me just try and make that more cube-like. And there we go. So it's important that you can establish that when you get a diagram like this, that you can also see the sides and the faces and the vertices that you can't see. So moving on to our next shape, which is very similar to a cube, which is a cuboid. And again, we can see we've got 6 faces or 6 sides. We're going to have 12 edges, so that's 12 straight lines that make the shape. And we've also got 8 corners. So 1, 2, 3, 4, and 1, 2, 3, 4, giving us a total of 8. Then we're moving on to a triangular prism. So again, we're going to have 8 faces, so we've got 8 sides of a triangular prism. We've got 9 edges because we've got 9 lines. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. And we're going to have a total of 6 corners. So we've got 1 corner there, 1 there, 1 there, 1 there, 1 there, and 1 there. Now for a square-based pyramid, we've got 5 faces and we've got 8 edges. So 1, 2, 3, 4, 5, 6, 7, 8. And we've got a total of 5 corners, which is highlighted on your screen. And then with a tetrahedron, we've got 4 faces and we've got 6 edges. So 1, 2, 3, 4, 5, 6, and we've got a total of 4 corners. So 1, 2, 3, 4 corners. Now an easy way to calculate the number of faces, edges and vertices of a polyhedron prism is if the cross-section shape has n sides. So remember that what we mean by a cross-sectional area. So if I draw, let's say, a cuboid, then the cross section is the face that's repeated to make that shape. So I'm going to go for this side being my cross section. And so the number of sides that that's got is going to be 4. So it's got 1, 2, 3, 4. So the number of sides equals 4, and that is my n value. So if that is the case, if you have got a polyhedron and you can't visualize the shape or it's not been drawn for you, then to work out the number of faces, it's simply going to be n plus 2. So in this case, it's going to be 4 plus 2, which is 6. So that's how many faces it's got, which we know. The edges is going to be 3 times n. So if n is 4, then it's going to have 12 edges, which we've already showed is correct. And the vertices is going to be 2 times 4, which is 8. So as an example, if we just zoom in on this, and just bear with me. So here we go, and this is our little notes that we've got. So here we can see that we haven't got transparent shapes in which we can't see all the sides or all the edges. So on a cube, I'm going to assume that this is my cross section in which n equals 4. On a cuboid, we've just done n equals 4. On a triangular prism, this is a cross section, so n equals 3. And on a hexagonal prism, we've got n equals 6, because there's 6 sides of that cross section. So to work out the number of faces, that's going to be 4 plus 2, which is 6. For the number of edges, that's going to be 3 times 4, which is 12. And the number of vertices, well, that's going to be 2 times n, so that's 2 times 4, which is 8. And again, the same thing applies for a cuboid, so they're exactly the same. For a triangular prism, the number of faces is going to be 3 plus 2, which is 5. For the number of edges, it's going to be 3n, so that's 3 times 3, which is 9. And for the number of vertices, that's going to be 2 times 3, which is 6. Then for a hexagonal prism, again, n equals 6, so the number of faces is going to be 6 plus 2, which is 8. For the number of edges, it's going to be 3 times 6, which is 18. And the number of vertices, that's going to be 2 times n, and that's going to be 12. So a much quicker way, if you can remember those little formulas to work out what the number of edges and faces are on a polyhedron prism. Now another thing that is linked to this topic is the net of 3D shapes. Now the net of a 3D shape is like drawing of the shape that has been unfolded and laid flat. Imagine opening a box and spreading it out. A net is basically what you will see. Now if you cut out the net, fold it along the lines, it will turn back into the three-dimensional shape. Now to draw a net or identify a net, think about the faces of the 3D shape and which faces connect with which face and by what side. Now often the net of a prism will have two identical faces, which will be the cross-sectional area or the shape that's repeated, along with rectangles, whereas the net of a pyramid will only have one unique face, and this will generally be the base shape, along with several triangles. Now how these questions are often presented in an exam or in a test is often like this, where you're given a 3D shape and you need to match up the net of the shape. So if you'd like to have to pause this video and have a go at these questions and then unpause as we go through the answers. So looking at question 1 or round 1, let's have a look at these questions. So for the first one, we'll have got a cube. So what we're looking for is, in this we've got 6 squares. So we're looking for a net that's got 6 squares, so that one is going to be B. With 2, we've got a cuboid, so here we're looking for 6 rectangles. And the net with 6 rectangles is going to be D. Then with 3, we've got a triangular prism. So what I've got here is I've got 2 triangles and I'm going to have 3 rectangles. And that's going to be option C. And then with 4, we've got a square-based pyramid in which I've got 1 square and I've got 4 triangles. And the only net that can be, and the only one that's left, is going to be A. Then moving on to round 2, we've got 1 circle and we've got, let's say, an arc or sector, I should say. And so that one is going to be B. With a cylinder, we've got 2 circles and we've got a label that goes around the cylinder, so that's going to be a rectangle, and that's going to be option D. With 3, we've got a tetrahedron, so we're looking for 4 triangles, in which that's going to be C. And then here we've got a trapezoid, which is the trapezium-based prism, in which that's going to be A. So here I'm looking for 2 trapeziums and 5 rectangles. And then if we have a look at round 3, so again, if you want to pause the video and have a go, match up which the 3D shape with its net, and then unpause once you've completed it, and we'll go through the answers. Now looking at question 1, we've got a right-angled prism, a right-angled triangle prism rather. So what we're looking for are 2 right-angled triangles, and the only one that's got 2 right-angled triangles is B. Then we've got what looks like potentially an equilateral triangle, or one triangle that looks like that, and that's going to be the net of C. And then the one that's left is A, which looks like an isosceles triangle prism, which is going to be A. And there we go.